Welcome, everybody, and thank you for joining us for today's webinar, Turning Climate Data into Stories. We are really excited for this one. It's one we've been working on for a while. Over the next hour, we'll help you better understand where to find reliable data sets, how to navigate specific tools, and show examples of a journalist effectively applying this to their work already. For those who aren't familiar, Climate Central, we're a nonprofit, non-advocacy organization really focused on researching and reporting about our changing climate. At Climate Central, we develop broadcast-ready and publish-ready data and visuals for you to apply to your storytelling and communication. I'm Bernadette Woods-Plackey. I'll be moderating today. I am the Chief Meteorologist here, VP for Engagement, and Director of Climate Matters program, which many of you are already a part of. Thank you. If you are not, we will share the link for you to sign up. This is our weekly package of material and ongoing education that we provide to really help advance climate reporting and communication. This briefing is being recorded, and the recording will be emailed to everyone after this meeting. And today's webinar is going to be the first in a series of data webinars that we are putting together. So many of you have asked us over the years for different ways to apply data to your reporting, and so this is a byproduct of that. We'll start with this one. Another one coming up is going to be focused on data visualization, and one on health data specifically. So, as we go through this, we really want to make sure that we provide practical and useful information. So please share with us, whether it's in the Q&A or I don't think I'm supposed to encourage chat, but ways that we can best support your climate data journalism. And also we will have a survey at the end. I'll have more on that. And as you're going through today, think about what would be most useful in helping you moving forward. So today, we're going to walk through two of the most practical tools available to journalists. ACIS, which allows you to query station-level climate data, and Climate at a Glance, which provides trend context across a range of geographies from city and county all the way up to regional and national levels. During today's webinar, you're going to hear from some real rock stars here. Our climate data journalist, Caitlin Trudeau, who's Senior Research Associate at Climate Central, and also Jen Brady, Senior Data Analyst. They have mastered climate data in almost every way imaginable. And also the privilege of joining us today, David Condos from Southern Utah. He is a reporter at KUER, and he's already been doing tremendous work working through data and finding stories in that data and bringing it to his audience. Now, after the presentations, we will open it up for questions. We're going to save time for that. So make sure that you share those in the Q&A feature, even as they come up. You don't have to wait till the end. So we'll have those ready to go once we are finished with our presentations. Now, first up, we're going to have Caitlin. She's going to walk us through the platform ACIS and how it can help you dig into the data. Go ahead.
All righty. Share my screen here.
Caitlin, it's a little hard to hear you.
Can you hear me now? Okay. All right. So hi, everyone. My name is Caitlin Trudeau. I am the Senior Research Associate for Climate Science here at Climate Central. I've been here for the last about 7 or 8 years, and getting to know the Applied Climate Information System has actually been one of the biggest parts of my job. So I'm really excited to just share it with you guys today and talk a little bit more about what you can use it for. So what is ACIS? We talk about ACIS a lot like it's just a database, but it's really so much more than that. It's a free, publicly accessible weather and climate data platform. So it was developed by NOAA's regional climate centers. It's maintained by them. They basically manage the complex flow of information from climate data collectors to the end users. And so what it does is it really integrates all kinds of data. It's historical data, it's also near real-time data, and also station metadata all in one place. And what's also really special about ACIS is that it's not just a database, they actually provide sector-specific tools as well. So in addition to these ACIS tools we're going to talk about today, they also have regionally specific tools that are maybe relevant to you. Frost maps, they have things about cattle and heat, they have snowfall climatology, all kinds of different basically tools that they've made to help people access data. So the key features of ACIS, first of all, there's just tens of thousands of US weather station data from federal, regional, state, and local networks. So the primary network is the Global Historical Climatology Network, the daily data, but they also have other networks like ASOS and co-ops, COCORAs, things like that. And most of these stations have historical records extending back many decades, some even back to the late 1800s. So it's really long-term data that really lets you have like a long-term context of how things have changed. And then they have a bunch of different variables that they have daily temperature. So you can do minimum temperature, average, maximum precipitation, snowfall, snow depth. They also have degree days, heating degree days, cooling degree days, and growing degree days. And all of this data is it's quality checked and it is updated every single day. And it truly is, in my opinion, a national treasure. Okay. So just some of the data products that you can use in ACIS. There is daily, seasonal, and annual time series. You can look at climate normals, daily climate normals, monthly climate normals. You can look at how today's temperature compares to those normals or how those normals have changed over time. You can also look at extremes. You can see if today's high temperature was a record and how long that record goes back. You also can look at first and last dates. You can look at the first date of the first freeze. You can also look at the date of the last freeze to kind of get you a sense of the growing season. But you can also do that for other things as well. And I wanted to show this because this is just a collection of some of the graphics we have created with data from ACIS. So these have all been created with local climate data from all different places all over the country. And as you can see, very different themes. And it just kind of shows a good range, I think, of all the different things that can be done with this data. So it is actually the very first thing that I was asked to do when I started on my first day was to learn how to use the ACES. So I've been doing that ever since. So some of you probably already have used ACES. And there's actually several different ways that you can access it. So there is a website that's called XMACIS that was originally created for National Weather Service users. Then they made another one that was called SCACIS. That was made mostly for state climatologists. In the beginning, it had some differences between the two, but now they basically offer the same data. The only difference is that with XMACIS, you're going to want to know like National Weather Service office codes and things like that. If you don't know a lot of the National Weather Service stuff, recommend SCACIS. They also have a query builder. This is for more advanced users who like to use APIs and are comfortable with like JSON files, things like that. But for most users, SEASIS is really the thing to we recommend. So I'm going to kind of switch over and just do a couple of show you a live demo of what we get from ACIS. So if you visit this website, you'll basically see this. I just want to point out because my eyes are getting bad. There is a setting here where you can actually increase font size. You can toggle accordion. So just wanted to point that out. You can deactivate tooltips if that's kind of distracting. But really over here is the menu of all the main products that we use. So really when you come over here, we start at the product selection. ACIS offers single station products from weather stations, but they also offer other things like gridded data products, multi-station products. They also have a dataset comparison tool, and they also allow you to look up just weather station information by itself. The things we use the most are the single station products. And so you can see the list of products here. They range, so you could look at daily data, you can look at monthly data, seasonal data, extremes, daily, monthly normals, all the things that I just talked about. And so one of the things that I wanted to show is one of the most common things that we do, which is we look at seasonal average temperatures. So we use this one a lot. We go to the seasonal time series. And when you select the product, it will open up the option selection. So here you have some options on how you want the data to be output. You can have, they'll show a graph, they'll have a table below, or you can select this to have some text that you can basically copy and put into a spreadsheet. It's comma delimited. And so next you come over here and choose variables, kind of what we talked about. We have temperature, precipitation, snowfall. For this one, we'd want to look at average temperature. Um, this here is, you can look at if it was precipitation, you could look at the sum, but you can choose maximum, minimum. If you also want to look at the day where, like, for example, you had a maximum temperature above 100, you can do that as well. You do maximum temperature, number of days, and then it would allow you to enter a temperature. So that's how we do that as well. But for now, we're going to look at the average seasonal temperature. We look at over 240 stations now across the United States. So whenever we do an analysis like this, we start our analysis in 1970. And that's mainly because if we extend it back further, we have a large portion of our stations that have missing data and errors. So we try to go back as far as we can. 1970 is as far as we go. When you're looking at climate data, you're going to want to have at least about 30 years of data. Um, so we're just going to start in 1970 and look back through last year and look at the average summer temperatures. You can do monthly temperatures. It doesn't have to be seasonal. You also can select other if you wanted to just look at the average temperature over like a week, 2 weeks, 3 weeks. If you want to look at a certain date, you can use that as well. But they have the traditional, seasons up here, annual, spring, summer, fall. So I'm going to select summer. They also allow a season calculation method. You can average the months or you can average the days. Um, and they have, different uses here. If you hover the tooltips, they'll basically say which ones they recommend. For this one, I'll just say average of days. They also allow you to set a maximum missing. And this is really important because one, you might have seasonal data, but maybe you only have 2 or 3 days out of the entire season. And so you have an average of that. It's not really going to be representative of the actual season. So one thing that we do typically whenever we have a graphic with a trend on it is we set a maximum missing value to 10%. We do not accept more than 10% of missing values. So for the seasons, we just basically put 9 here, but you can put whatever you'd like. And then
Caitlin,
here,
I'm going to interrupt for just 1 second because a
yeah.
lot of numbers here. Why 10%? Why are we going with something like that?
So that's actually something we saw in the literature that's commonly used. But we also recommend that people make their own decisions about what they're comfortable with. And I think that, depending on what kind of analysis you're doing, what your audience is, all those kinds of things, you should make that decision for yourself and for your team. So that's why we do that. Um, and yeah, so one other thing we do is we include the regression line. So this is the trend line on the graphic. It adds a least squares regression. Um, and that is an option. You don't have to use it. They also have a moving average that you could add as well. You could look at a line graph. You could look at bar charts, whatever you'd like. This next part is the station. And for many people, I've heard them say that they don't know how to find a station near them. And that's what really stops them from being able to use something like this. So I wanted to show this example because by the time you get to this point, you are allowed to basically search for a station. Let's say that you work with weather station data all the time. You know the codes. You know what a global historical climatology network daily code is. You have an ACIS code, a ThreadX code. You can just enter that in, select ID, enter the ID, and it will recognize that. If you don't, you can just say search, and you can just search for any city. So I am in Sacramento, California. And so you can enter where you're from. It will show you all the stations in your area. Um, and sometimes it'll have different types of stations. Sometimes you'll see like a raindrop that's a Kokoro station. These are basically our GHCN stations. And you can find one and you can double click on it to find out information about that station. And this is actually a really important part of selecting a station, not only because you get to figure out, where it is, what the ID is, latitude, longitude, elevation. It also tells you what type of data is available for that station, and it gives you the available date range. And one thing I really want to caution people for is that when you look at the available date ranges, that may be the start date and the end date of the data, but it also may have a bunch of missing data in between those dates. So it's really important, even if it says it has this really long period of record, make sure and double check that there's not a bunch of missing data in between those two dates. And so we can come here. You don't have to do anything else, but just come back down here and click go. And then you're going to have a graph right here. So this one, it looks like there is missing data. So the earliest that it goes back to is 1998. So it basically shows the data here. You can hover over and look at the exact values. You can zoom in if you'd like. And then here's the table where you have the actual values. You can sort them. If you want to sort by year, by average temperature. It's also going to tell you the missing number of days. And that's going to be really important for context as well. You can rank it. And then if you wanted to just copy and paste it into a spreadsheet, it's best to kind of select this CSV option and click go again. And then you can see you can just select it, copy it, and paste it into a spreadsheet. So that is how you get, stations data for a single station. If you were going to be looking at data for a lot of stations, let's say you want to look at stations all over like your county or maybe all over your state or even the country, you can use the multi-station products. But really, if you're going to be looking for a lot of data, we recommend using the query builder. And we don't have time to get into that now, but please reach out if that's something you're interested in, because we would love to help you use that as well. The other thing I just wanted to show is one of my personal favorites here. It's called the accumulation graph. And what it does is it shows you how much precipitation you've gotten this year relative to other years. So you click on, go to single station products, accumulation graph. The options will come up here. And I want to look at this year, and I just, I live in Sacramento. We've gotten very little rain. And I want to just compare that and see how dry has it really been. I want to compare it to the normal, the 30-year normal, but I also want to look at the highest year and the lowest year and kind of just set that for context. So when you press go, then you get to see this accumulated precipitation up to basically yesterday and see how it compares this year to the normal. So you can see in Sacramento, we basically became below normal pretty soon after the new year, basically since January 20th, we've had below normal precipitation. But you also get to see these really interesting highest year lines as well. These are really interesting if you live in an area where there are hurricanes or there are single day floods that are just really extreme. You can see some really interesting context. And there's some really interesting storytelling that these graphs can actually do. So I really recommend them for anyone who wants to see whether give context for how dry it's been or how wet it's been. It's really a great resource for that. If you want to just download the graphic here, you can click on this little tab here. You can print it, you can download it as a PNG or a JPEG, you can download it as a SVG vector image or as a PDF. So that's another option for you if you don't want the data, but you just want a graphic that you can quickly use, you can do that as well. And I think that is it for me. I think now Jen is going to take us to the next one.
Real quick, before we get to Jen, a couple of points of clarification just for people to follow along. A few times, a little bit of terminology that I want to make sure everyone's following. What is CocoRAS? What is G? Could you explain to people CocoRAS and
They're
GHCN?
station networks. Yeah, so they're different kinds of weather station networks. CocoRAS is a citizen science one where anyone can sign up and be a part of it, measures precipitation. But then there are federal, local, regional, even global weather networks that are also contributing data to this database.
Yeah, so for people to understand there too, CocoRAS is really citizen driven. So if you want to jump in on this, this is a great way to do it. And you can explore so much other data there too. It's really fun. And one last thing too, for some people just understanding when we're talking about station data, that's a single point, right? Or a connection of in the immediate area. Caitlin's also done a ton of work with grids and larger spaces. And so that's something we're going to get into at another point. But just to understand that that is at one point when we talk about station versus a grid. And there are differences in different processes you bring into really understanding and navigating how best to find the stories in that. But this one right now, ACIS is just such a core tool for so much that we use that it really can help you learn a lot and find stories that are worth telling. So Thank you, Caitlin. With that, we are going to shift now over to Jen Brady, who's going to bring us through another really important tool that we've used for so much of not only our work, but understanding where to go with our work. So I'm going to hand it over to you, Jen.
And one last thing about ACIS, because I can't not talk about ACIS, is it's updated basically real time. So station people will update it. So you can probably get yesterday's data today. So it's very, very timely. So sorry, I just had to say something about ACIS. Let me just a second. We're going to do a presentation. I'm hoping to do a live demo, but there have been some glitches with Climate at a Glance over the past couple days, so I cannot unfortunately promise that's going to happen. So we can do it all with the presentation, and if we can, we'll go live. So I'm going to talk about Climate at a Glance, which is kind of going up a level from the station data. So a little more summary, like Byrne said, is how we tend to use it when we're looking at kind of bigger storylines. Oh, I should introduce myself. Jen Brady, data analyst here at Climate Central. I have been here about 12 years now. I think as of next month. So again, yeah, much like Caitlin, I've been playing with this data for a long time. So what is Climate at a Glance? Great site, first of all, we should say. It's free, publicly accessible weather and climate data platform, just like ACIS is. This one is available from NOAA's NCEI, which is the National Centers for Environmental Information. This is such a smidgen of what they offer. So I just want to put that in there to begin with, is they are an incredible resource, and we could probably do multiple webinars on just NCEI resources. So this is just one of their greatest hits. There's data at the global, the national, the regional, the state, the divisional, and the county level in the Climate at a Glance. I am going to skip like the city level because we'd recommend you kind of go with your station data for that. So I'm not really going to talk about that in my presentation, but it is in Climate at a Glance if you want to. And I think I'm one slide to mention that. So you can access visuals on this, and you can do data downloads as well. So this is your home screen that you're going to go to when you go to Climate at a Glance. You can probably, if you Google Climate at a Glance, it's going to be your first hit, which is really nice. It's really easy to remember how to get to it. And you'll see here again the repeat of the levels, the geographic levels I mentioned, the global, the national, the regional, the state, and then the main types of data sources you can get. You can do mapping, time series, rankings, Haywoods, and the data info is just kind of like, it's starting in this date, it's, you know, these states are included, these states are. So I'm going to walk through these for a lot of the different levels. The other thing, they added these, I think it was last year, these tutorial videos, which are really nice. So definitely recommend, if you're interested in Climate at a Glance, spending a little time on this tutorial videos, because they're really, really nicely done. So going to start at the top. We're going to start at the global. And as we said, we have all these different ways of looking at it. This is, if you pick the global mapping, what you would see. The global, it's fairly simple variables you can look at. For example, this one is the average temperature for 2 months ago. This is the ranking. So kind of the really red areas are the warmest. You can also look at this as temperature anomalies. You can see that's one of the other options here. I'm going to go through the global pretty quick because they're pretty straightforward, and we're going to dig down in some of the other ones. Time series, probably a very familiar graph to a lot of people who have seen global temperature graphs. This is the global temperature anomalies. Again, there's only a couple options. You can do land and ocean, you can do only land, or you can do only ocean. Those are kind of your different geographic parameters. And your two main weather parameters are temperature anomalies or precipitation. So again, you'll see when we get to the other levels, there's many more options than these that they're on for the global. Again, global also anomalies. They're not temperatures. That's a whole other discussion we could have. But just to remember, these are all in temperature anomalies. And you see, you could pick your time scale. You can pick your month where you end with the time scale. So for example, in this case, we often do a year. So in this case, I do a 12-month time scale, and the month represents the end. And you can verify that if you look down on the graph, you'll see it says January to December. So that'll help you make sure you got that time period right. The start year for global is 1850. It's the longest one you're going to find in all the data sets. So you can go all the way back to 1850 for the global data. The rankings. This is, I think, what we talk about a lot. To me, this is one of the more complicated tables on climate at a glance. There's a lot here. So I'm just going to kind of give you a preview. I think the color coding is very nice. It helps you quickly get some sense if you don't want to really dig into it. Here I've chosen the precipitation rankings and the land and the ocean. And as you can see, the rankings, it was, and this was a little surprising to me, it was the second driest globally over this time period, the driest since. So this has a lot of information. It can be rather complex, but like I said, I think the visual cues of the colors are very helpful because a lot of times you are using this as a scoping tool. Haywoods, what we often call spaghetti plots. And so these will show you many, many years of data and will show you kind of the trends over the time. And this one, it's featuring really the high years and the low years. The high years, of course, being recent years at the top there. So again, this is the Haywood plots for the global. Going to dig a little deeper now because I think it gets a little more interesting when you get to the national and the local. So the national time series starts in 1895, a little later than we have with the global. The other thing I'm going to highlight, and we'll talk about this a little more, what I have to the box to the right here are some of the base periods you can pick, and you can display the trends. These are not necessary. If you don't want to, you don't have to select these. These are things that you can include to add context to your data. We often, I would say, don't necessarily include these when we're trying to look, particularly the base period. The trend is often helpful, but they can also be something that you may need for context. As you can see for the national time series, and you're going to see this for the other geographic levels, a lot more options than you have for global, a lot more options. You have all your temperature variables, you have your precipitation, but you also have some really interesting cooling degree days, heating degree days, some drought parameters. So there's a lot more offered at this level. I am going to be rather boring and talk about temperature parameters in my demonstration here, but I definitely, I'd say just kind of side note, the other one, other than the temperature and the precip, we love cooling degree days. So we use cooling degree days a lot, and it's a really, really informative one. So that's what I would encourage you to play around
Jen,
with.
I'm going to jump in for just a second because I don't know if everyone understands heating degree days and cooling degree days.
Oh gosh. I have to explain this in 10 seconds. So basically it's a measure of, I'm not going to go into the math of it, though the math is pretty straightforward. It's basically the amount of days you have to turn on your air conditioner, turn on your heat. It's kind of an estimation of that in engineering terms. So what we're seeing obviously is many more days when you would have to theoretically turn on your air conditioning, which is cooling degree day, and heating degree day, we're seeing going down. So it's been a really kind of interesting story to tell because electricity prices and the burden of air conditioning in particular is a really important story when we're talking about global climate change. So as I said, I'm going to go with a kind of straightforward one, average temperature. This is your national time series. I did put a base period on here. A standard base period is 1901, kind of, the last century, and I included the trend here. One thing I will remind people, and I forget to do this all the time, is look at your start year and your end year and your trend start year and end year and make sure they match, probably, because you're probably going to want them to match, because sometimes I will say change the start year to 1970 and I'll forget to change the display trend starting in 1970, and you're going to kind of get a mismatch wonky. So just another reminder here. We're going to step kind of down through this graph a little. Another important thing here that we use sometimes really quickly is under the boxes. You'll notice kind of small, again, like Caitlin said, you have to learn to read small print, where it says 1896 to 2026 trend, and it says 0.25 degrees per decade. This is a nice way we often use to kind of summarize how much change there has been over time. So for example, if you multiply that by the total of number of years, you're going to get the total time change over that decade. Or you can just look at different states, say, relative to each other, and say who has a higher change per decade is going to give you some context. So there's so much information on these, really so much information. We're going to jump into the statewide. Statewide, again, we have another start date. We have our 1895 start date for the statewide time series. Special note, there are Alaska and Hawaii, but their start dates are later. So just be aware that if you're kind of doing a complete 50 states, the Alaska and Hawaii start dates are going to be later than the other series. Again, same variables that you see for the national, same selection of variables at the state level, same sort of choices. Here I did Missouri average temperature for 1 month. I didn't do a trend line in this one, for example. So maybe I'm just kind of scoping to see what the overall pattern is, maybe looking for a high year or a low year. Now I added the trend line in a base period, a little bit of context. The other thing you can do is you can actually hover over. So maybe you are just kind of trying to figure out what a certain temperature was in a certain year. You can use the hover, and you can hover over to check out what the average temperature was. The other thing is you get data. The data's at the bottom, which is great. So you can either just look at it, but you do have download options as well. So you can download the CSV, the JSON, or the XML file if you want to download the data. Also love the rank. The rank is very helpful, especially when you're kind of seeing how are we doing this year relative to other periods of time. It counts. Well, it doesn't really count backwards, but it counts from like the cold. So a lot of times when you're thinking of the warmest, it's kind of, you have to do kind of the reverse math. So I didn't do the map for national because it's a bit boring. So I will feature, because it's just one color for the whole nation. So, but I'll feature here the statewide mapping. Again, same parameters available: temperature, precip, cooling degree days, drought index. There's options. You can pick the value, you can pick the anomaly, you can pick the rank, the mean. Again, I picked the rank, which tends to be a more popular one to look at. So in this case, we had for the January to December, so it's last year. Bad news for Nevada and Utah, right? I'm like having like state problems.
Yes,
Yeah.
Utah.
We're looking at the warmest here. But it's a really, again, a very nice, quick visual tool, particularly when you're scoping data. A Haywood plot for the statewide ranking. Again, here's just the average temperature, and you can see how the different years build next to each other. I'm not going to go through all the details because it's the same again and again. The county time series, you can pick the state and the county, same variables. Divisional, if you happen to know what climate division you live in, you can pick your state and your climate division. And then there are city level ones. These you can go in and it will show you which cities are available from it. But again, we recommend if you're doing at that downscaled level, it's probably good to think about doing station level data if you can. There's just a kind of a precision to it, which is nice. Though, if you look here on the third column, that is actually the station ID. So you could actually take that ID from this tool and use it in ACIS, and it should give you the same data. So all of this is fundamentally built on the station data, just sometimes it's a little more embedded. So I think, Shell, how am I doing on time or burn?
Yeah, a little more.
Okay, let's try.
We're at 1:35 just for a time check.
Let's try the tool. Okay, so here is climate at a glance. Let's go to states. Again, you can just click through. I click to states, and then again, like I said, I'm just going to kind of some of our favorites, which is the time series, to look at something. We'll try something different. So we'll look at precipitation look at my home state of Ohio last year. So this is fairly straightforward, fairly quick once you get the hang of it to do. I will display a base period. I'll put in a trend as well. And as Caitlin said, a lot of our analysis, you'll notice, are from 1970, which is when really we have found the most universally consistent data across our stations. This is where I'm saying, make sure you go in and change that trend So it matches your new period. Just hit plot. Lovely. The precipitation is increased. Here you can see in the corner what has changed for decades since 1970. If you scroll down again, you see the different options with the data. It'll show you the ranking, it'll show you the total, and then it also shows you the anomaly from your base period. So if I altered my base period to say, use the climate normal base period, oops, it will adjust that. I'm good with data, I'm bad with cursors. So we changed our base period, and what that's going to do is change our anomaly here. So that may be somehow where you're going to use your base period. So I think I'm going to leave it at that, Burn, so we have time for any sort of questions and digging in.
No, that sounds great. And there have been a lot of questions popping up already. So continue to bring those to the Q&A. We are answering some of those as we progress so that we don't run out of time. So if you're in the Q&A feature there and you want to click on the answered tab at the top in the middle to get some information on where to find hourly data, information about wind data, information about what cooling degree days are. And we did have a question about Haywood, but then you did answer it, Jen. So thank you very much. All right, speaking of Utah, since we know where to find it on a map now, we are going to bring in David, who is joining us. And he is in southern Utah, and he is going to be talking to us a little bit about how he applies data to his storytelling. So, David, bring us in a little on your story of how you approach the data, how you find the stories, how you bring this out in your storytelling.
So I just want to say I love these tools too, and very glad that you all are getting more information out to journalists and folks about this because I think they're super useful. And so I use the ACIS tool a lot, commonly for the seasonal time series, which Caitlin mentioned, looking at temperature and precipitation across a certain time. And at this point, I've used them enough where a lot of times I'll be keeping an eye on the data to see if a story is there. Like as that is developing, I'm like, oh, this month or this season has seemed really dry or seemed really warm or whatever. And then I'll look in the data and see if there's something to back that up that then I could go and interview some experts about impacts and that sort of thing. So at this point, for those specific tools that I've used many times, I'm typically keeping an eye on it even before that time period is over to know like is it on track to have some kind of anomaly that might be worth a story. But then like there's some of the tools you all had talked about today I haven't used as much. I know there's tons of data in there that I'm not as familiar with. So yeah, I'm still discovering new ways to use it. And like I even just helped a colleague of mine here at KUBR who was looking for some like watershed specific precipitation data for a time period. And so I figured out how to help them find that. So I think the cool thing is that a lot of the data, if you're wondering if it's out there, a lot of it is out there. It is being tracked and is available to you. And so the more that you kind of learn how to use these tools and get familiar with it, the more you'll know kind of what's possible, like what you could be watching or what could back up, something that you're seeing and hearing. Yeah.
One of the interesting things with precipitation we found, especially out where you live, is that since you don't get a ton and it can be really concentrated on a day or two, how you dive into extremes versus averages or things like that, because then there's different stories to tell, right? Because
Sure.
an extreme can overwhelm a system, but it may not show up as big on an average. It's just another way for people to think about how to get into this data, play around with it, and see where there might be a story here or there. And again, if you have any questions, really, you're always welcome to reach out to us. Caitlin and Jen breed this stuff. Ton of people on our team are really up to speed and we can help you navigate this. So David, we have a story that you're going to share with everyone. We're putting in the chat here. Can you bring us up to date on how you approach this story and how you
Sure.
use data for it?
Sure, absolutely. So this is a pretty straightforward example of what I was describing a few minutes ago. So it was a lot of stations at cities and national parks and various places across Utah recorded their warmest winter on record for this winter, that meteorological winter that just ended. And so in this case, I live here. I was experiencing some of the anomaly, and so I was able to keep, like, even before winter ended, I was able to keep my eye on that data and see, like, oh man, like there's a bunch of stories here, or there's a story here because there's a bunch of communities that are on track to break these records. And so in this case, I was able to kind of have the story ready to go by the time the date came when the meteorological winter ended. And so I brought in, some experts, and I talked to someone from a local, ski shop about, to talk about impacts. And yeah, then I was able to turn this data into some data visualizations, which you can see if you click on the story. And this is the type of stuff that I've probably done the most, and maybe I'm most comfortable with. But it's really awesome because, like uh, Kaylin was explaining earlier, even within ACEs, you can also see the 30-year normals, which have been really useful to me to see, like, okay, well, we know what we got this month or this winter or summer or whatever, and then you're able to see, well, this is how it is divergent from our 30-year period that is our kind of historical average. And so that kind of stuff is just, I don't know, is fun. Like, I feel like the more it is really overwhelming to start. And so that's why stuff like this is great. And actually, one tip I have is, if you have questions, you can reach out to Climate Central, obviously, but you can also, like, if you're doing a story and you're interviewing your local National Weather Service meteorologist, like, they use all this stuff. So, like, that's how I learned. Is I was just interviewing folks, and I'm like, hey, like, where are you finding this data? And so they, like, walked me through it. And so there are a lot of folks that you may already be interviewing that could help you kind of find your way to a piece of data as well. But yeah.
That's a really great tip because it can feel overwhelming when you come to these tools at first. I mean, I'm even grounded in data and have been doing it my entire career. And one of the first times I got onto ACIS, I was like, where do I go and what do I do? So having someone guide you through some of that, or as we're trying to do here today too, is helpful, and just sort of confirming that journey along the way. And as you learn more, you see more. One other thing too, just for people to bring everyone along with this conversation too, normals, when we talk about 30 years, that is a really foundational chunk of time on how we look at averaging out our weather, because we're always going to have these ups and downs in the weather in days and months and years. And when we take a chunk of 30 years, that gives us a snapshot of what is average over time. Now, those averages and normals have really been changing. They've been going up, and they're updated every 10 years just to reflect. We've done some analysis on the changing normals too. It is on our website if you want to go find that under the resources tab. But that's a story unto itself, how the normals keep stepping up over time. And even when we're judging warm or cold on those normals, that's on a changing baseline on how this is happening too. So, David, anything else to leave people with today as they're starting or continuing their data journalism
Yeah,
journey here?
no, yeah, I would just say, kind of to reiterate, I think it does seem really overwhelming, and I was there as well with the first few times I got onto ACEs. But yeah, find someone who can talk you through it, and, like, especially, like I was saying, in my experience, like, these National Weather Service folks, like, they're really happy to do that. Like, they're excited that you're interested in these tools that they care a lot about and use all the time. So, like, it's not an imposition to them to have you ask questions about
It's
it.
so true. They would love to talk it. And the other thing too, to everyone out there is, again, as you get up to speed too, this is where you're in such a unique role to be able to apply the storytelling to those numbers, as I was explaining why that mattered in Southern Utah, right? So that's fantastic.